Okay, correcting for seasonality. Now, this is very different to interpreting a seasonal index, and very different. So in the last video, I showed you how to work out seasonal indices. For example, if you have a seasonal index of 1.3, that's 30% above average, etc., etc. If you have a seasonal index of 0.7, that's 30% below your seasonal average, etc. If a question says to correct for seasonality, this is not interpreting your seasonal index. This is working out how much we need to increase or decrease the actual sales figures to correct for seasonality. So it's often not the difference to adjust that back to 1, the seasonal index to 1. It's the proportion of the seasonal index to put that back to 1. The easiest way I can explain it, and I'll rub this out in a second. If I have 80 cents, right, which as a seasonal index, 0.8, it's 80% of the seasonal average, so it's 20% below. If the question asks me to correct for seasonality, what would I need to do to this 80 cents? A lot of the times a student will say, oh yeah, you just increase by 20%. That's actually not correct. If we think about the seasonal average being $1, right? If I increase 80 cents by 20%, that is adding on to 80. 20% of 80 is 16 cents. So that is 96 cents, right? I haven't got to $1, have I? Because if I'm starting at 80 cents, I need 20 cents to be added to that in order to make it $1, which is the average, right? So 20% as a proportion of this 80 is actually 25%. So 20 cents is a quarter of 80 cents, isn't it? So I have to adjust this by 25% to make it 1. All right? So just be careful. Very common exam question. It's usually a multiple choice question, but who knows what they'll do this year. If that does come up, correcting for seasonality or adjusting for seasonality, etc., etc., you need to do the following. I've thought about this, and this is the easiest way I could think of to make sure that you get this correct. So what I need you to do is, if you see correcting for seasonality, to adjust for seasonality, etc., this is the formula you need to use. So you're going to have 1 over the seasonal index minus 1, then times 100. If you get a positive number, you're going to increase by that much, and it will be a percentage. If you get a negative number, you're going to decrease by that number. For example, for the 0.8 that we did before, if you put in your calculator 1 divided by 0.8 minus 1 times 100, what do you get? And if I bring up... Okay, so I've just added in a little calculator grab here. So as you can see, I've gone 1 over 0.8, which is the seasonal index, minus 1, and I've put that in brackets, times 100, and I get 25. It's a positive number, so I'm going to increase by 25%. All right, so I have to increase this seasonal index by 25% of itself to bring it back to 1. All right. Now, another example, if my seasonal index is 1.5, I don't know why I put a 0 on the end, 1.5, to adjust for seasonality, then what do we need to do? So I'll give you a couple of seconds to have a go at this in your CAS. Right, just taking a little grab from my calculator. So 1 divided by 1.5 minus 1 times 100. This time I'm getting a negative number, negative 0.33, negative 33.33333. So I need to increase, decrease. So negative number, decrease. So I need to decrease by 33.33%. That is honestly the easiest way I could think about making sure that you definitely don't get this wrong. I have taught it in the past where I just go, you could do 100 over the seasonal index, and then you adjust what do you need to adjust from 1 to get to that number. So you could think about it like that. This way, I kind of feel like it spells it out for you which way you have to go. Positive number, you increase by that much. Negative number, you decrease by that much. And you just don't talk about the negative in the question. All right, I might go through a couple of questions just summarizing all the seasonal indices stuff. So this will go on from the last video as well. So for example, if I'm deseasonalizing data, so deseasonalizing means taking off the seasonal effect. If the seasonal index for a cold drink sales for summer is 1.33, so interpreting that, this means it's 33% above the seasonal average. Last summer, a Beaches kiosk actual cold drink sales totaled 15,653. What were the deseasonalized sales? So deseasonalized figures are given by our actual figure divided by the seasonal index. So the actual figure is 15,653 divided by 1.33 is equal to $11,769.17. So that's taking off the seasonal effect of us selling more drinks, cold drinks in summer, basically. Second example, what does the seasonal index of 1.34 tell us? So this is interpreting the seasonal index. So it's 34% above the seasonal average, or it's 1.34 times the average. All right. What does a seasonal index of 0.65 tell us? So the difference from 1 is 35, so it's 35% below the seasonal average, or 0.65 times the average, or seasonal average. Next question. To correct for seasonality, if the seasonal index is 1.34, so we go 1 over the seasonal index, which is 1.34, we minus 1, and we times by 100. And then you pop that on your calculator. So it gives us negative 0.2537 So the answer is decrease by roughly 25.37%. So if this is an exam question and it's not a multiple choice, while this is helping you work out how much, like if you're decreasing or increasing, etc., make sure you don't put the minus in there. The minus is just a little equation that I've sort of put together to help you work out which way to adjust for seasonality. So this is the actual answer. All right. To correct for seasonality, the seasonal index is 0.65. So 1 over 0.65 minus 1 times 100 is equal to 53.85. So it's a positive number, so we're increasing by 53.85%. Is that? Yes, that is the end of that. So that is, in a nutshell, how to adjust for correcting for seasonality or adjusting for seasonality. Very different to interpreting a seasonal index. And we just went through a few questions of deseasonalizing data and interpreting seasonal index and also correcting for seasonality. Hopefully this has helped, and this will help you finish off 6D. Cheers.